Hello everyone, welcome to ITS 454. Welcome. So today we are going to, today's lecture, Tuesday, we are going to go over a new topic, which is, last week we started looking at just, sniffing and spoofing, right? That initial concept of sniffing and spoofing, and you guys have your homework assignments for those. Now on Thursday, during lab time, we can go over that homework again, sniffing and spoofing. If you have any questions about any code, I do ask you though that try to come up with your own solutions, and then that way you'll have better questions, and then we can solve everything. So that should be pretty straightforward, I think. That homework. Today's homework is a little bit harder. Today it'll be Tcpip attacks. However, there's very little coding in this one. In this assignment, it's mainly about doing things in the network. We'll be using a tool called NetWalks. Scapy here won't really work because Scapy in Python is too slow, and some of the attacks require a little bit more speed. So that's why NetWalks, which is a better tool for that. But we might look at scripts as well. So what we're gonna do today, although most of the classes that we cover are defense, really this class today will be about offense, I guess. So let me share the screen. So you should be seeing bright space now. Should be seeing bright space now. If you look, I have a couple of slides here. Certainly read through these slides. Basically a lot of the things that I'm going to say today, I'm going to make notes on the whiteboard, but they're in the slides. Okay, so you can always just reference the slides. Obviously, also chapter 15 of your book is called Tcpip Attacks. You should just remember you should be reading. So the chapter for this week in your book, Internet and Network Security, is chapter 15. So make sure to read through that. My notes are coming from that, plus they're in the slides. You can take a look at the slides as well. All right, and then of course the PDF is really, remember that this class is mostly about solving these problems on labs. And so that's what we're going to be doing now. So today basically I'll start the discussion of TCP/IP. So obviously this is a protocol that you guys are already very familiar with. You've covered this in your networking class. So I'm not going to go over the protocol itself. I'll mention a few things about it. But then after that, we're just going to start exploring this new class of attacks, right? This is a class of attacks that exploit the vulnerabilities in the protocols. And it's not really that there's vulnerabilities in the protocols. It's more so that that's just how the protocols work. They have a specific way of working. And because they have that specific way of working, then clever attackers will try to game it. It's like that expression, gaming the system, right? The system does its thing, but the attacks try to game the system. Okay, so we'll take a look at that. So I'll discuss that today. There are actually a lot of attacks that we can cover. If you notice there's a lot of attacks. We're not going to cover all of them. So definitely, certainly pay attention to the ones that I'm going to discuss. As you can see here, there's the two slides. There's also going to be just my notes. Here, I just provided this little file. This is for a particular attack, right? So there's a particular attack where I've just provided the commands for you. It's a bit of a tougher attack to get to work, and so I just gave you the commands for it. And then here, these are the two PDFs. Right, so as you've seen, this is actually the very recent PDF. But since they just upgraded in January, the seed labs, I kind of just want to make sure that if they have anything interesting new in there, that we also do it. But I looked at both of these. They're very, very similar. But certainly, again, make sure you read both documents. This is a lab that's a bit longer also. This will probably be a 2-week lab assignment. So that's really the plan. I will introduce the tool called NetWalks later, and I'll provide some commands just kind of give you an idea of how it works. You will once again need Wireshark for this one, setting up the network, and so on. So there's going to be a lot of details for this one. But basically what it has in common, once again, is network packets, okay? So let me actually, so, you know, there's a lot of diagrams in these two, so certainly take a look at them. Very interesting. You can see here, I just, you know, you see the slides have the scenarios, so certainly take a look at them. I usually will just draw these same things out on the whiteboard. So it helps me to think a little bit better. All right, so let me see. Before I continue, I just want to do the course participation. This is the last week for that, I think. But let me get your names. Let me just pause the video. Video is recording. Audio should be good. Okay, so let me switch over to the whiteboard. All right, so this week, we are going to talk about, last week we talked about sniffing and spoofing. So we talked about sniffing and spoofing, and hopefully that makes sense to you now. You know, sniffing is just what? It's listening to the network traffic, right? Grabbing the packets. Basically, you looked at some packets for specific port numbers, ping packets, you capture the password for telnet, that kind of thing. And that's what firewalls, intrusion detection systems, and even attackers, when they do man-in-the-middle attacks, etc., that's what they do. They try to, they capture your packets. We saw that there's basically a library called libpcap, and pretty much Wireshark, everything else, Scapy itself, they're all built on top of that library. We saw that we can code. It's kind of hard to code it in C, but we saw that it's pretty easy and straightforward to code it in Python. Spoofing, that's just kind of the other side of the coin. That is creating basically a buffer and then having all the right headers, Ethernet, IP, and if it's a TCP packet or ICMP packet, putting in all the little fields, and then dropping a packet in the network. So that really is what spoofing is. As you can imagine, that basically, as long as we can take over the network card, we have the root privilege for that, then we can generate any kind of packet. A spoof packet is basically by definition, an anomalous packet, right? Something that should not be there because you defined it. And so now we're going to take this idea in particular of spoofing, and we're going to take it a step further, right? So the last problem that you did was combining sniffing and spoofing. You would cap, like the example of pinging 1.1.1.1 or 1.2.3.4, right? So we send a packet, we sniff it, copy it, reverse it in direction, change a few flags, like changing it from being an echo request to an echo reply, sending it in the network. So that's a spoof packet, right? And we were trying to trick somebody pinging that spoof packet they thought was a reply. So that's probably one of the more satisfying problems in that set of problems that you have in your first assignments. Today, as I said, this week, maybe the next 2 weeks, we're going to be taking the concept of spoofing a step further. And now we're going to take it to the point of creating network attacks, right? So we're gonna think, remember, it's this idea again, it's not that we're attacking like in software assurance where we're attacking code that it was poorly written by a human, right? So it's not really that. Here we're looking at code that's correctly implemented, right? The code is correctly implemented, but attackers are just trying to take advantage of how things work in a connection, and basically they're going to try to exploit that to obtain their objectives, right? So I always want to say that, you know, these attacks in this course, network security, are definitely a different class of attacks, right? They're not malware, they're not you know, any kind of virus or worm, they're not, you know, buffer overflow vulnerabilities or web security or anything like that. They are their own family or class that are basically packets in the network. That's why the word spoofing should be there, because really they are, the name of the class should really be spoofing, network spoofing attacks, right? That's really, you know, the common theme that all of these have. Imagine it's like a train car, right? So it's a train car, and these trains are always moving around, but you hijack parts of the train, right? And then that you can change a lot of it, all right? So that's really the intuition, okay? So that's what we're gonna look at this week. Now, as far as writing the packets, we have basically two ways of doing, well, three ways actually. So far, you know, to spoof a packet, because of course, if we're gonna make attacks, we need to create fake packets. So to spoof packets, you can either, and this is, you know, I leave it to you guys, honestly, to do it however you want, but the options are obviously C, C++, oops, C, which you learned last week. Obviously, this gives you a lot of power. If you master this, we saw that the best code was the memcopy code, forget the exact name, but that one did sniffing and spoofing, so it allowed you to send out ICMP packets. Then I provided 3 other files, which gave you even more flexibility. This, obviously, in terms of everything, is the most versatile, fastest, etc. Then we have the Python approach with Scapy. That's super easy. And then, you know, that one, but unfortunately, it's not as fast. So not as fast. But it is versatile and easy to use as well. And so sometimes, I mean, we can certainly spoof a packet. We may just not be able to achieve the speeds and efficiency of this one. But certainly we'll take a look at both of those. And we'll come back to C, C++ several times over the semester, you know, when we start looking at client and server architectures, you know, like when we do the VPN lab, for instance. And then now, today, or this week, I should say, there's also tools, right? There's tools in particular that we can use. And the tool that we're going to use is NetWalks. All right, so that's the tool. So instead, really, so anything that you could do here or here, you can do with this one. And this is not coding. This is just a tool, but it's a command. It's got 2 approaches. It's either command line, or it's going to be it's got a GUI interface, and the GUI is called NetWag. Both of these are installed on your virtual machine. So the CVM has NetWalks already. So I'll really just give you some examples as we start discussing the lab. Also in the PDF, I think the commands are there. But you can always just ask, right? So I'm always happy to answer your questions, but I'll show an example. So this is something, you know, now the way that I recommend always that you do this is that you start with the GUI, you know, start crafting the attack in the GUI. I'll give you some hints, and I'll give you some hints, I guess, some examples. And, you know, the great thing about the NetWag is there's a button. So whenever you're crafting the attack on the GUI, you press a button and it actually prints out the command line. So it'll give you also the command line, because it does become more practical to run the attack from the command line eventually, especially if you want to automate a more complex attack. Let's say calling netwalk's command line from Python, for instance. So remember, to do that, you can use Subversion, right? And that will allow you to make the calls on the command line. All right. So this is basically the tool. So as far as how we can do most of these attacks can be done with netwalks, and I would recommend that you do it that way. But there are those of you that probably want to do it with C or Python, and that's perfectly fine as well. At the end of the day, all three: spoof a packet, put it in the network. That's pretty much what it is. The other tool that you will use heavily for this lab is Wireshark, because you probably had some experience already with the first lab, sniffing and spoofing. Wireshark is really handy at figuring out what's going on in the network. What packet did I just send? How does it work, etc. Now, there are a lot of course, as you guys know, and you can look at the slides there. There's some examples of packets, right? The structure of a packet, how it can be created. We can look at the slides. So I'm really talking about attacks here. And I already mentioned that this is a new class of attacks. I would call it spoof attacks, if you will. These are active attacks, not passive. All right. So what that means, you're really literally trying to do something. You're trying to affect the principles of confidentiality, availability. So these are some very interesting attacks. So that's certainly the case. We'll talk about some of the countermeasures that we have for this. I'll talk a little bit about them. Some of them have to do with encryption and cryptography, obviously. All right, so I have a slide here that I want to share with you guys. All right, so you should be seeing this slide now, I think. As you can see, data encapsulation, you guys, this is a topic you guys studied in your networking courses. And as you know, that's the whole, OSI model, right? So we understand that, we got our protocols, Ethernet, IP, and TCP, and then upper layers. All right, so that just means that whenever we send a packet, which is, a byte stream, we have the different headers, right? So these are the headers, the layer 2 header, or the Ethernet header, if you want to call it that, the IP header. Then you have TCP, UDP headers. Usually there might be, we're just going to say this is, the payload. I already showed you in the C code, right? We described that whenever we grab a packet, we basically link data structures, all the different headers, and then that way we can manipulate the fields in each one of these headers, right? So that's, you had an example of how to do that in Scapy. That's what you were doing in the previous lab. So hopefully that makes sense, that really one of the objectives of those labs was to get familiar with this concept. So now this week, we're gonna focus on attacks that kind of have to do with TCP and IP. In particular, not UDP, so we're not going to explore those. And we might also explore a few other things, ARP and so on. So there's a lot of labs actually, and actually not enough time to cover all of them. But we'll cover some of the major, more interesting ones of this class of attacks. Okay, so we'll take a look at this. Switch back to the whiteboard. Right, so as I said then, we will be talking then about attacks on TCP IP. Okay, remember this is chapter 15 of your book. I strongly recommend you read the chapter. There's always a lot of great information. A lot of the commands and everything are always there, and you may miss them if you don't read the chapter. So definitely read the chapter before you do the lab. Okay, I would recommend that. All right, so okay. So we're going to start talking about, first of all, just a little bit of TCP. I'm just going to mention some of it a little bit. And then after that, we're going to get into the types of attacks that we will be doing. As you know, for a lot of these, you're going to have to build some kind of a network again of computers. So for instance, here I have a few diagrams. I usually describe these in the whiteboard. But you know, there's the ARP, so we'll talk a little bit about how to make ARP, what I'm looking for there with ARP, and then there you should be seeing the ARP slide. Okay, so we'll talk about that one. We'll talk about a very interesting one, Tcp Session Hijacking. So this is probably the most complex one that we're going to talk about, but definitely all the information is here in the slides, and you know, as time, this is probably the last problem, so it'll be the one that will take the most time for you. But a lot of the details are here, and I'll go over them as well. We'll also talk about Tcp Reset and Syn Flooding, and you know, and we'll see from there. So as soon as I think we've covered a good number of them, that should be enough. So here I think I have, yeah, ARP attack, telnet reset, spoofing a telnet connection, which is a really interesting lab, denial of service, so on. And basically the scenarios will involve, you know, having some kind of several computers, right? And usually in a lot of these, there's the idea of a client, there's the idea of a server, and then there's the idea of an attacker. Because what we want to have usually is we want to have some connection, right? What we would call a secure connection. And then we're going to look at that, and then how the attacker tries to attack basically that connection in some way. All right, so unfortunately for these labs, sometimes we may need 1, 2, or even 3 computers. Okay, but you know, if you can do them with just 2, that, you know, that's perfectly fine. All right, and notice here it's usually, you know, some kind of a TCP spoof attempt that we will be trying to create. But to spoof a packet, we need to understand, and this is, in a nutshell, this is it, right? So there's some kind of a connection, right? Because it's TCP. So we have this idea of a tunnel, a connection established. And then, depending on what it is that's going on over there, we need to put a packet in the network, and we need to modify all of its fields so that it'll mimic the packets that, for, you know, a packet that we want based on what we want to achieve. Okay, so that's really the idea. So it'll be then, you know, figuring out what to spoof is really the key. And there are times in some problems where actually we need to send more than one packet to be successful, and so on. So that's really the scenario that we're going to talk about for this assignment. And I haven't really even talked about the PDF yet, but I just want to give a little bit of an introduction of the main idea. All right, so let's go ahead now, and so it's TCP, right? So what do we know about? So we got, you know, we have this, the OSI model. You guys know this, TCP built on top of IP, and our focus will be here in TCP types of connections. So what we know about TCP is that it is reliable. it's meant to be reliable, right? There's always an acknowledgement, right? That, that's what is meant by reliable. It's like, I sent some data and I just don't just assume that it got there. There's some kind of a sense of reliability and acknowledgement, right? And that actually plays into the attacks. And so there's reliable and also ordered communication. Right? And that just means, when you send the data may have sequence numbers, and also then attackers know that. All right, so they're saying, okay, there's some kind of established connection. There are sequence numbers that are being used. I need to think about this, right? So obviously, in a lot of these attacks, if things are encrypted, that creates a problem, right? So because if something is encrypted, that requires you to have keys. So obviously all these attacks have to do with unencrypted things, not the encrypted payload that's in the packet, etc. It's just really talking about the packet itself and how it communicates, okay? We're not trying to deliver payloads either, okay? So not usually we aren't. Instead, what you're trying to do is just send the basic packets and their functionality, right? We're trying to exploit those ideas. When we do other attacks, like if you were sending malware or SQL injections, or if you were sending buffer overflow attacks, okay, those are concerned with the payload because the packet is just really delivering, something that will go into an application, like a SQL, like an input, which would be a SQL injection, like a shell script, which would be a buffer overflow. None of these attacks really have to do with payload, okay? They just have to do with exploiting the protocols and how packets trigger things in the operating system. Now we know TCP, for instance, is widely used. TCP, we use it for the browser. We use it for SSH. Telnet will be a good example of things that we can do, just given that it's it's a tunnel, it's unencrypted, so it's the easiest that we can use for our understanding. Email, right? Use TCP. All of these services are TCP. As you know, TCP is basically, it's called the transport layer. So this is called a transport layer. And the definition of TCP is that it provides host-to-host communication services for applications, right? So TCP is host-to-host. So there's some kind of a, there's no real tunnel established, but there is this idea of a concept of a tunnel where you have a channel basically between port numbers on a client and a server. So we're always going to think in terms of that, a client and a server. On the other end, a UDP, which is something we're not really going to cover in this lab, does not provide reliability. Right? So it does not provide reliability. Okay, so but our focus will be just on TCP. So as you know, what this means is, you define basically this idea. We initialize, we do like a three-way handshake, right? Some kind of a connection, and that just virtually we can think of it as there's a tunnel, right? And whenever we send information to that port number, it arrives on that end. And so those port numbers on each end, on the client and the server, are basically tied to applications, whatever application we are trying to exploit. So, the classic example that you already did in the previous lab when you tried to steal the password was Telnet, right? So you started up a telnet service, and you started up a telnet client. And then from the client, you try to communicate. All right, so what we know here, obviously, if the tunnel, like in Telnet, is clear text, you can see everything. So without crypto, this is not secure. So we know that. But we are not so concerned with that right now because we're only exploiting how the protocols actually work and what could be ways of gaming the system. All right, that's really the intuition that we want to get. So without crypto, this is not secure, right? Because it's you can see it. However, as we're gonna learn, even though a tunnel may not have cryptography, it does have built-in mechanisms to provide some security, right? Like the sequence numbers. So we're gonna look at what that actually means, and then that it'll be hard then to exploit that vulnerability, but we're gonna try. Right? So the key thing then, we have a tunnel that has been established, a connection. There's no crypto. So really what the attacker needs is the attacker just needs to understand the protocol. Okay, so that's really all that is needed, is to understand how the protocol works. So now, so really, before we start talking about, okay, attack, this attack or that attack or this attack, or, we want to go at a more fundamental level and just say, what are the things the attacker can do? That's really all that, we want to take a look at. Right, so I always draw this, like that, kind of, imply that this is across the internet somehow, right? So we have a connection between a client and a server of some kind, because TCP is our focus. So what can the attacker do, right? So what are the things the attacker can do? So the attacker can eavesdrop, right? You already did this one, right? You did it on the telnet, stealing the password. So that's done. You've already done, so let's call this a pipe. So then we can say eavesdrop on the pipe. Number two is we can inject fake data into pipe. So remember, again, the tunnel just means that we have all these packets which have a specific kind of a header, right? And that header allows, the client to communicate with the server communicate back with the client, right? So now what we want to do as the attacker is that I'm going to change colors here to blue. The attacker wants to inject the packet, wants to know that header, and so that the attacker can now impersonate the good packets, right? So that's what injecting fake data in there is, right? So that you can actually send a bogus connection, for instance, right? So inject fake data could be something like, a denial of service attack, right? So you're a bunch of spoof packets trying to establish connections. So you're throwing them in the network, right? And they're basically fake. Another thing that the attacker could do is break the pipe connection. Break pipe connection. So that's basically, again, going back to this example, you have the correct packets being sent back and forth. The attacker sends their bad packet, and then all of a sudden, when it's received by one end, boom, they break the channel. And so now when you break the channel, these packets are no longer recognized, right? So they want to break the channel. And so that's really another thing that we're going to do. It's a TCP reset type of an attack, okay? So we're going to take a look at that so we can break the pipe. And then finally, and really the more interesting of the attacks, I would say, is we could possibly try to hijack the pipe connection. And this is the more interesting example where, if you think about it, if this is telnet now, if this is telnet, right, that means that we're telnetted into the server from the client side, right? So really, when you think about telnet, you're sending commands, right? So you're sending ls. So you're sending the ls, let's say on the server, you want to run the ls-l command and see the contents. So via telnet, you would send those commands like that. However, what the attacker wants to do is, when you're just waiting, let's say that you sent ls and now there's no packets in the network, but the connection is still there, right? So the ls command already ran and you got your output, and now think of the server as just sitting there, right? Waiting for the next command. So instead of the client going in and typing something in the command line, it's the attacker himself or herself that will pretend that they have a command line, right? And then they'll say something like, just anything. I mean, it doesn't have to be an attack, but it's just, let's say, netstat something. Netstat, all right, or something. We can even do a reverse shell. So we'll do actually a reverse shell later on, but let's not complicate it so much right now. Let's just think of a simple example like netstat, a command. Well, spoofing these packets to pretend to be the correct packets, the packet would be inserted, sent to the server, and even though when the server replies, right, it only can reply to the client, right? So it'll never reply to the attacker. It doesn't matter, because by the time the server replies, the command has already run here. So let's say, netstat will still run in the server itself, even though maybe the attacker will never see the response of it. It doesn't matter. The command ran, and that's, it could be something worse, right? Format c ... something like that. And as I said, we can even create a reverse shell where with a reverse shell, you can actually then establish another connection, boom, back to the attacker. So that, is a way of hijacking the system even further, okay? So hopefully this makes sense. These are the 4 things, if you want to call them that we can do, right? So that we can do. So usually these, they'll be very interesting. You've already done this one, right? Just eavesdropping the traffic. You stole the password, hopefully, and you saw how straightforward that was. And that just required, this one just required sniffing, right? But certainly for these, you're going to have to do spoofing. And then, we might do other things as time permits. I want to do these, the TCP ones first, make sure we get those done. I believe you guys have done ARP and things like that in other courses, but we might actually take a look at that as well. I mean, there's some interesting, from the point of view of spoofing, there's some interesting things to consider. Okay, so now let's think a little bit about what we want to do. So in the lab, for instance, in the lab, and obviously we need to read through the PDFs. There's going to be a lot of detail there, but we will cover 3 main attacks. So in lab, we will cover 3 main attacks on TCP, which actually have names. And we will look at some of the defenses as well, obviously, you know, why things exist. Okay? Question? All right. So 3 main attacks. Remember, you know, these notes are in your book. So if you've read the book already, you can see that they're there. All right. So the 3 attacks are called Syn Flooding, and you probably have a notion of how that works. This one we're going to use NetWalks. Now, Syn Flooding would work on anything, right? So it would work. It would work on, you know, a computer, a local host, server, Linux, Windows. It would work on a router. So you can always try to attack a router. Obviously, a router that has a lot of memory, etc., might be a little bit more robust. And a single attack from a computer may not be enough. But that's why sometimes there's something called a Smurf attack. I think it's in the slides. And that just means you attack several servers. But those servers, what they all do is they do a Syn flood on a specific machine. So you multiply your capacity for an attack. We'll take a, it's in the slides, so you can see that idea. It's something like, let's say you have all these computers over here. Your target is actually that. But if you just Syn flood it yourself, that computer may be resourceful enough. So what you do is actually you attack these, and then their response is actually towards that machine. That's what your goal is, to get them to broadcast all to that machine, and so that that increases your attack, if you will. So it's pretty interesting, and you can look at the slide there. All right, and then so Syn flooding is one. That's the name of it. So remember this, okay, guys? Remember that I need to see the Syn flooding. There's going to be one called Tcp Reset. It's pretty interesting. This you can actually use, if you live in a dorm or something. I'm not saying you should, by the way. Actually, you should not. Let me rephrase this. Do not use this against your roommates to break their internet connection. But whenever you're established, you're downloading something, streaming maybe a video, you can always reset by targeting that IP, and it resets the connection. So we'll explore this one as well. And it's actually very easy. That one is very straightforward. There's only involved is just a netwalks command. So usually with a lot of these, you just type netwalks. So this is on the Linux machine, netwalks. And then every attack, and that's why I'm mentioning the attacks by number. I will give you the numbers later. I don't remember right now what they are. I mean, netwalks has 200 attacks, I think, and they're all referenced by number. So let's say, I think it's 72, 78. So you do netwalk 72 or netwalk 78, and then you specify some flags or parameters, which are going to be, you're spoofing packets. So if you're spoofing packets, what do you expect? The IP header, you need to say what's the source, where's the destination IP. I want to spoof the source. I want to send at a rate of so-and-so. I want to send Syn packets, and I want to target port 23 or some kind of port like that. Remember, with a lot of these, as I gave the command last week, somebody had a great question about services. Whenever you want to see what port numbers you have open on a machine, you should type netstat -tna or just -na, either one. And then you remember pipe, right? So you're going to this redirection, as you learn in your Linux course 372, and then just grep whatever you want in there, because there's going to be a lot of output. So if you want it UDP, you type UDP. If you want a TCP, you type TCP, and then it'll show you the open ports and so on. And then the other one that, you know, the more complex one that we're going to look at, this one actually is pretty hard, actually, I would say, to get it to work. Understanding the concept is not difficult. It's just getting it to work is difficult because the TCP session hijacking, as it's called. Again, we're going to try to spoof, and our goal will be, you know, what I was saying before. We want to do this scenario that I described over there, where a connection is there, but you want to insert a command into the server. So for you to be successful in that problem, I need to see that you have correctly inserted the command. And you know, we can insert a command, a basic command, or you can insert, you know, one command, I remember now, the command that I usually like you to insert there is PWD. Oops. PWD. Because PWD gives you the path, right? The path of the current working directory. So that's a good one. Usually, when you do this, the server will send the client the PWD. Also, obviously, you can see that in the Wireshark, right? So when in Wireshark, you can capture this packet, and I've accepted that for some students, just showing me, if you just show me, at least in the Wireshark, that you captured the packet that was sent as a response from the server to the attack, and it's the packet that was sent to the client, I'll accept that in the Wireshark. Other students are successful in showing the path here in the output itself. That's actually the one that I would prefer to see. But you know, there's a certain level of complexity. So we'll talk about that one because it's a bit tough to get to happen. You have to use Wireshark extensively, and that's only because of the sequence numbers and the acknowledgement numbers that are associated with this type of a communication. So we'll, as I said, we'll talk about it more specifically as we get to it. And obviously the PDF does provide a great discussion of it. Also the book provides a great discussion of it. And also in my slides, I added already 5 or 6 slides describing all those details as well. But we'll discuss it as we keep going. So this one is called the Tcp Session Hijacking. I don't remember the command. I think it's netwalks 40 for this one. I believe it's netwalks 40. And as I said, when you go to the GUI will say Tcp Session Hijacking. Oh, by the way, that's, you know, netwalks 40. This one's a little bit more complex because spoofing this packet requires a lot of parameters. So if you imagine what you did last week, where you had to go into the mem copy code and you had to grab all those fields and kind of replace every single one of those fields with particular values, that's really all we're doing. I mean, there's really nothing, you know, that's why we start with sniffing and spoofing, because at the end of the day, we just need a machine that generates a blank buffer as a packet, and then we just change the values of all the fields in the usually in the IP header, the TCP header, and once we know exactly what we want that will mimic that connection in the network, boom, we drop the packet. So just to give you kind of a, so this will require a lot of parameters, but just to give you a kind of an idea, so let's say that we have in this attack, you know, we have our connection, right? And then, you know, this is machine A, this is machine B. Remember, one is client, one is server. So there's gonna be data sent in both directions. So there's data here, but there's also data, let me change the color, right? Because, I don't know, it's maybe, let's say it's web, right? It's HTTP connection. So it's a browser connecting to Apache or, you know, something like that. So they're both exchanging data in some way, right? So there's data, you know, imagine there's data there, I don't know, something, 700, you know, 700 bytes, whatever you want to say. Now, as you know, TCP, you know, it kind of gets data in a buffer and then it starts sending it in chunks. sometimes big chunks, sometimes smaller chunks, depending on how the protocol works. So what it does is that data could potentially, let's say it's 300 there, going in that direction. Those two packets can arrive, they take different directions, and maybe the 300 arrives before the 700. However, to address that, there's going to be the idea of sequence numbers. Right? So these packets have sequence numbers so that when they arrive at the other end, they can be reconstructed appropriately. And that's really actually the trick. It's also not, it's not just for reconstruction, but it's also for security, because the sequence number, the initial sequence number is actually a random number initially. A random number, and it's a big one. I think these random numbers are like 32 bytes, I want to say. So they're big numbers that would be very hard to guess, in a dictionary type of an attack, right? And so, so that's the idea. And so guessing the numbers is difficult. That's why, and then as you add data to it, it's going to be plus, data, the size of the data, or at least +1 if there's no data in the packet that you're sending. But the sequence numbers not just allow for reconstruction, they allow to make sure that those packets belong to that tunnel, to that connection between A and B. If you arrive there, if you spoof a packet, but it doesn't have the right sequence number because you didn't choose the right random number, then it'll be rejected. And so in a sense, for you guys, when you do your assignment, that will be the difficult part, guessing those random numbers. However, what we're going to do to simplify things, obviously, is that you can use Wireshark to capture the packets, or you could use SniffX to write your own program. It's up to you. Either do it manually with Wireshark or write the code yourself. But you would need those parameters to go in the command. So when we do the command, the netwalks command over here, this one, you always need to get those sequence numbers correct and all the other parameters. And of course, the sequence numbers change every time you run things. Every time you break the connection, start it again. Also, every time you insert a packet in the network, and it's an unfriendly packet, a spoof packet, it's gonna break. A and B are gonna get confused. They're gonna be like, ooh, what's going on? And so you'll see that in Wireshark, and then it becomes a little bit harder, less friendly to spoof packets. So anyway, it should be, these are the three main attacks that we will start with, certainly. These two are easy, I think. This one's a little bit harder. And then from there, we will work our way. The order in which you do them, that's entirely up to you. It doesn't, the only thing I would recommend, do this one last. Definitely hold off on TCP Session Hijacking until the last one, because all the other ones will be more straightforward. Okay. Are there any questions so far, guys?
No.
Right. So how does TCP work? Right. So that's, you guys know that. I'm not really going to get into that. But just remember, we're really talking about, TCP client. Simplest one, honestly, is Telnet to use. TCP server. Now, you can always simulate a service, right? So you know this, that you can always simulate a service instead of grabbing like Apache or grabbing Telnet or grabbing one of those. You can always just simulate one. A couple of ways of doing that. C, C++ code. In your book on chapter 15, it shows you the C code to create a client application and the C code for creating a server application, and then allowing those two to talk. I'm not going to ask you to do that in this lab. We will, however, use those two little programs when we look at the VPN lab, because in the VPN, we need to establish a tunnel, and then we need to look at encryption, and that will bring in like TLS and SSL. So we're gonna hold off on that part for that lab. for this one, so no need for CC++, but instead, another way, you can also do Python. So if you remember in 372, I actually showed you guys how to do a service with Python. I think we simulated Apache. And so there's Python. And there's an even easier one, even easier way, which you probably should remember also from 372 when you did the file system analysis, and that is to use Netcat. So Netcat allows you, NC, right? Netcat allows you to create a service. So you can always do like -L, list, which means listen on some port, pick a port like 9090. So you bind the service to it, and then you make it verbose, for instance, and that just allows you, that port number now, you know, you can send information to it, right? So you can build basically a tunnel with both Netcat on both ends and send data around. So at the end of the day, kind of similar idea, but this is what we're exploiting, these little tunnels, because, you know, these little tunnels don't exist, but the packets themselves have little headers of agreed upon parameters, sequence numbers, etc., that allow for the connection to seem like they're in a tunnel, right? So that's really the idea. Anyway, so that should be how, you know, how TCP works. I guess I should write here how TCP works. All right, so now I think we can start looking at let's look at yeah, let's just look at one example. Let's start with one example, the denial of service attack. Okay, and then we'll come back to the other ones. But let's just look at this one first. So that's the Syn flooding, right? So Syn flooding. So I'm getting a question here. A student is asking. It's a good question. So he says, I have a question on the TCP hijacking task. If we have both the server and client and know all the details and still have to guess on sequence number, isn't there a more realistic way you would attack or hijack? Well, that's the point of it, right? So the sequence number is literally the defense. So you're not going to, the only way that I would say is if you do something like sniff and spoof. So you literally have to have code that captures the packet. Do you see that? It needs to be really quick. It needs to grab the packet, one of the packets in that connection, copy it, right? And then send it out. Does that make sense to you? Whoever asked a question?
Yeah.
Do you understand what I'm saying? Yeah, so because he's asking, because really, yeah, what you're going to do in the lab is you have either one of two scenarios, right? One of two scenarios. One is you use Wireshark, but as you said, that's manually. It's the easiest for you as a student, for you just to get an understanding. But to make the attack work, it has to be automated somehow. And the whole point of the sequence numbers, and we'll see that. I mean, this is a principle of, you know, almost of cryptography, right? That, you know, you know that the keys of a certain size are unbreakable just because of the size of the key. That the security relies on that, and this is very similar as well. You start with a random number that is going to be very difficult to do a dictionary attack because these things move so fast and they're changed constantly. And so, but really, if you wanted this to work, assuming there's no cryptography involved, you would need to have a man-in-the-middle attack where you sniff and then you spoof, similar to the 1.1.1.1. Okay, all right, so I think that answered his question. It was a pretty good question, actually. So let me know if you guys have other questions. Great question. All right, so we were talking about Syn flooding, right? So Syn flooding attack, and this is also described pretty well in your book, and I've already provided a lot of slides in the PowerPoint as well, so you can take a look at that. So all I want to talk about with the Syn attack is really how it works. Yeah. All right. So really what it does is basically you guys know that for TCP connections, there's something called the three-way handshake, right? So there's the three-way handshake, and really there's going to be an exchange between the client side and the server side, right? So a packet is sent, a packet is sent, and then a packet is sent, right? So that's really Syn, Synac, and ACK, right? So that's really the idea. You can see that. So these are just packets with individual flags. So if you imagine you want to spoof a Syn flag, there's going to be 4 little flags in the packet. So you just have to set that to a 1, let's say. And then you do Syn plus ACK, and then that's just going to be 2 fields with a 1, and so on. So what happens basically in this type of an attack is that when you do this, the server has, imagine, a buffer. And a buffer just means, space and memory. And whenever it gets a packet, let's say the packet comes in, it creates a little record of the packet. Then another packet comes in. When this happens, it receives the Syn, it sends the Synac. At that moment, it creates another little record of it. Then another connection comes from another place in the world. Syn, it sends the Synac. And then it keeps doing this, and it's waiting that the client will send the final packet in the three-way handshake. When it gets that third packet, let's say for this connection over here, then it removes that from the buffer, and it just creates, an established connection. So imagine there's like a table, and now there's an established connection with all the parameters for that connection in the packets. Do you guys see that? And so you keep doing that, right? So the problem with the Syn flooding attack is that you're talking about millions of packets being sent, and the goal is, guess what? To overfill the server so that when you see the connections table, you don't have, let's say there's 100 connections, 1,000 connections there. You don't see 1,000 established connections. You see 1,000 Syn received connections, which basically means they're what are called half open connections, right? So the CPU, so if this is the server, right? Imagine this is the server. So the CPU, the RAM, the GPU, all of those are idle. They're not basically at capacity by any means. They're pretty much idle. So there's plenty of resources there. But the problem is this idea of a queue or a buffer, as it's called, of half open connections gets full. And the problem is once it's full, what happens? If you get other connections from other places, there's no more room because it's still waiting for the ones that came first, right? In theory, first come, first serve, kind of a first in, first out, right? So FIFO. So it's waiting for that kind of packets, and then that becomes, that's why it's called a Syn flooding attack. You affect the availability of the server. So you affect the availability of the server, and therefore the server cannot respond to other things. And even though these things are idle over here, the server just won't be able to respond. So that's it, in essence, the general idea of this, right? The general attack. So that's what you guys will do. Now, one of the things that needs to happen for this to kind of work better in the server is that you want to decrease the size of this buffer. Okay, guys. So there's going to be a command in the PDF, as you might imagine, on the command line. You'll type something sys. I can't remember exactly what it is. CTL something. And that command will allow you to reduce the size of the buffer just so that you can see the attack be a little bit more successful. So the scenario, of course, will be pretty simple. You will have two machines, A and B. From here, you're going to launch netwalks. This will be maybe have telnet open, which is port 23. And then you're going to launch the Syn Flooding Attack. You're going to need to run netstat on here, -NA, pipe grep TCP. This will show the list of all the connections that are, it should show the list of all the established connections. But because you are running this attack, it's going to send, I don't know exactly how many, but I would say thousands of spoof packets. So the spoof packets will have a random source IP, right? So it's going to be random. So there's going to, because that's the whole point, right? That it's, if otherwise, if it's not random, what would happen? The firewall would say, why is this IP, source IP, sending me all these SYN packets? It must be some kind of an attack, so I'm going to block it. But if it's so many, if it's thousands and thousands of IPs, that it's, it might be harder for the firewall, so it might need to use other mechanisms to stop it. But otherwise, this is the scenario for the Syn Flooding Attack. What I need to see as far as your output is two things usually happen. One is that when you try to type commands on here, it becomes slow. Okay, so, but that's difficult for me to see in a screenshot, right? A better one is if you show me that this output, because here I would see a lot of SYN receives with multiple random IPs. And so if I see a lot of information here, SYN receives with a lot of IPs, I know that it worked. Okay, so I will know that that worked. But remember, there's two things that you probably need to do. Reduce buffer size, so that, that's just for you to get that to work sooner. And then the second one is actually, which takes us to the next topic, is you need to disable the defense mechanism. Okay, so you will need to deactivate or disable that defense mechanism. So that will be yet another command. When you type that sysctl something for the buffer size, also disable. Oops. Also disable. And so here's the mechanism. Anyone know what the name of the mechanism is? Anybody know? What the name of the defense? Right, it's called Syn cookies. So you're gonna disable Syn cookies, and that's what I'm gonna talk about now. Is Syn cookies? Basically, how does that work? Now that we understand the Syn flooding, right, and we understand that Syn flooding is centered around this idea of filling up this buffer. These are, they're idle basically, so they're not, and yet these are fully functional, and yet availability is, the pillar of availability is affected on this type of an attack, given that we just filled up the buffer. All right, so that takes us then to the defense mechanism for Syn flooding. And that is called Syn cookies. And Syn cookies, as as usual with security and network security, the thing that comes to the rescue is crypto. It's a cryptography. All right, so in particular, if you remember from your 350 course, so at issue is what? So let me ask you, I guess, this question. Why do you need, what do we put in this buffer? We put every single packet that comes in, right? A packet comes in from Texas, and then a packet comes in from New York, and then a packet comes in from Illinois, and so on, right? So we're keeping track. So think of it as that buffer, the so-called buffer in the server of the half-open connections just keeps packets of, Texas, and it keeps not the packet, but it keeps a record, right? It keeps some kind of a record, of the sequence number, right? So, it basically needs to have that sequence number, because that sequence number was randomly generated, unique, right? And so for the right connection to represent that tunnel, you need to have that sequence number. Plus, it keeps track of other things like an IP and those kinds of things. So, but let's go with this analogy of Texas, Illinois, New York, Louisiana, something, right? So you keep track of all of these. That's what you need. And eventually you have so many that it just fills up, and so you max out and no more connections are allowed. That's the problem. But because you have this connection between the client and the server, right? You have basically that, right? You need to keep track of that buffer. Now you could argue, don't keep track of anything. So you could say something like, you know what, why keep track of anything? Just, send a packet, you send the reply, and then when they send the last one, start all the connection. But that's also problematic, because the attacker could just spoof this last one. And then you would actually be accepting, so what's the problem there? The problem, what's the problem with this one? With just accepting the last packet, basically. What do you guys think? Why not just do that? Why do you need to do the three things? So it's really because you want to confirm that this person here is a real person. Remember, when you receive this packet, if it's spoofed, right, it's going to be spoofed from New York, but the attacker is in Indiana. What's going to happen? What's the server going to do? Who is the server going to reply to? Is the server going to reply to New York, or so this is the attacker. This is the spoof IP. So is the server going to reply to the attacker or to the spoofed IP? So New York or Indiana?
New York.
New York, right? New York, exactly. New York. But if it's a spoof packet, there is no New York. And so you know that. And so that's why you kind of want to do that. Whereas if you just accepted the last packet, well, you never checked if New York was real. And so that would be a bad thing. So you can't just take the last packet. So that solution doesn't work, unfortunately. All right, so you need to do then, so back to the drawing board. So I forget his name, unfortunately, but somebody very smart, it's in the book, came up with this idea. So you got your connections there, and you say, okay, I got the packet. I need to make sure that this person exists. So what you do is they send you a packet. They send you a packet, a sequence number of some kind, right? And that's what you're usually storing here. I'm storing this sequence number. But what you want is then you send that packet with that sequence number back, the SYN-ACK, right? And other information, but that's in there. And then you confirm New York gets it, and New York again replies, and it's got that sequence number. So that when that one arrives, not only did you check that New York exists, but you also check, oh, by the way, yeah, their sequence number is corresponding to my sequence number. Great. I got it to work. However, that's the problem. The person that came up with Syn cookies came up with a clever solution by using cryptography. So before I tell you, given the information that I've given you, is there anyone that would like to guess what you could do? Think about it, right? So if you remember in 350, we did a lot of things playing with cryptography. How could you build through cryptography something that might work a little bit better? What do you guys think? Okay, so some people are writing. Okay, so somebody's saying use a secret key that is only known to the server. How would you use that secret key though? I agree with you. So she's saying, okay, I have a key that is only known to the server. That's a good one. And then what? What do you do with that key? Anyone else wants to take a guess? All right, how about if I give you another hint? We also have a key and we have a hash function. What is a hash function? What was the definition? Nobody? Can you guys hear me? All right. So, all right. Anyway, what you could do is pretty simple, right? What does a hash function, what does it do? It's basically, it helps you with the principle of integrity, right? So it's, okay, somebody's guessing. Create a hash. Yeah, so create a hash, exactly, create a hash. You can create a hash of just the parameters inside this packet. So the idea is, okay, now everyone's guessing. Right, so the hash number creates, a hash value. It's a sequence of numbers, right? That's unique to that file. And usually you hash something, and if that object is modified even just by 1 bit, it'll be a completely different hash. But if it's the exact same thing, information basically, then the hash is going to check out. So the person that came up with Syn cookies, what they did is they quite simply said, okay, you know what? I don't need, you know what? Let's be intelligent here. We don't need to keep this information. what we do instead, now now there's a thing, and you remember, right? Remember that cryptography slows things down. So there's a hit to performance. And so you don't usually use Syn cookies all the time because that would slow down your network. You only use it when you feel that there's an attack going on. Otherwise, you just respond normally. So you still use this, but if you feel there's but only because you don't want to affect performance. If you do feel that there is a problem, though, you can activate Syn cookie. So what happens now is the sequence number in the Syn packet plus also, something like, everything, right? The source IP, destination IP, and a whole bunch of different information. Think of it as, I don't remember the name, but think of it as the profile. So it takes the sequence number, source IP, destination, well, that's going to be you, so probably not that, but other things, other parameters in the packet, right? Other parameters in the packet are all taken as a single little string or file of information. And then you run this, let's call this P for profile. So then you run this through the hash function. You run the profile and you have a key, as somebody said, right? And you run it. You calculate the hash value. And then that hash value, guess what? Can be sent here as the sequence number. Because when you do this sequence, right, and you do the acknowledgement and the sequence number and everything, you can provide a value, and you usually do in the protocol. So the value goes in there, right? It's sent back to the client, and then the client, when they send you that value back again. They send it back to you. And so now when you receive it now, you don't have anything here, but when you get this value, right, you can take the hash, right? You can reverse the process and check, or sorry, what you can do is you take the parameters in here, right? You take the parameters again. So you extract again the sequence, because the sequence is just going to be the sequence plus one. So if you think about it, it's only, you can always get the original sequence, because in the three-way handshake, these are only increasing by one. And so when you do that math, you still end up with a sequence, the source IP. You recalculate P, which is the profile and the key. It gives you a new, let's call it new value compared to, let's call this one old value, right? You compare both old and new. And if it checks out, you know that it's basically that person. So that packet that you saw initially in the Syn packet is the same one that you're seeing now in the last packet. And then that should check out. That's right. So somebody is asking me, the hash function. Somebody says, just to verify, we would assign the hash of the profile and the key as the, yeah, that is correct. It's the only place where you can put it actually. But yes, that is the definition of it. Does that answer your question? Okay, great. And that's it. That's Syn cookies, as you can see, a very elegant solution with cryptography, hash functions, and hopefully this makes sense, right? That you know, instead of giving a sequence number, you just assign those sequence numbers. As I said, I think they're 32 bytes anyway, so they're pretty big. So you can provide that information, and so that works really well for the Syn Flooding Attack. And then here just compares the values. If they check out, you basically then, you know, you validate it, because you were able to check over here, does New York exist for that spoof IP? If it does exist, then we're good. Otherwise, it, you know, you'll never get a reply, so you just ignore it completely. Okay, so that concludes, I think, Syn flooding. Check the slides. I'm pretty sure there's more information there. And then we can also take a look at the PDFs later. We'll take a look at them. All right. Okay, so next we can talk about the other two problems are going to be TCP Reset, and then session hijacking will be the last one that we talk about. So let's talk a little bit about, I guess. So again, we go back to this idea of a tunnel. Remember, the tunnel doesn't actually exist, but it's just the packets. Think of them as having a little header of the connection. Okay, so we have a client and we have a server, possibly telnet, to make it simple. All right, so now we're going to talk a little bit about how can we do other things, right? So let's go back to that idea of this idea of hijacking the pipe connection. So how can we do that? So the issue is that the issue here is inserting the malicious packet. Okay, into a TCP. Remember, these are all TCP. Into a TCP connection. Remember, we're not worrying here about cryptography or anything like that. We're only worrying about, you'd have to basically, if this was like a really coordinated attack, you'd literally have to have an insider steal those keys, break the cryptography, and then do this, do something like that. So the key question is, what is, this security mechanism that is used in the tunnel is based on the sequencing, sequence numbers. And that's really, I think we're not going to have enough time to finish this today, but I'll start it a little bit. Maybe I may have to repeat some of this again, because really what I'm going to talk about now is this idea, okay, of sequence numbers, and then kind of how they work a little bit, and then, how to get through the problem. So we use spoofing for this. So let's talk about, so the next topic is then sequence, TCP, sequence generation, TCP sequence generation, and something called PRNGs, right? Which you probably remember this also from the 350 class, pseudo-random number generators. Right, so we'll talk a little bit about that. All right, so let's think about this now. Upon connection via TCP/IP to a host or a server, right? The host generates they actually both generate numbers. The host and or server generate an initial sequence number. An initial sequence number. Okay, and these are called ISNs. Okay. And this sequence number is basically used in the conversation between itself and the host to keep track. So as I said, the sequence number is then used, you know, in the conversation. They're usually sending those sequence numbers back and forth. Very similar to the idea of that we saw before. So these sequence numbers are being sent back and forth, and they're basically for two things. To keep track, right? To keep track. To reassemble the data. To assemble the data. And basically as a security mechanism in the tunnel. Because those numbers are very difficult to guess, okay? Right, so without those numbers, as you will actually, in your lab, when you start doing this, you will break the connection. Every time that you do this wrong and you don't send the appropriate sequence number, you will see what happens. The connection in Wireshark, you're going to get all these strange packets saying that something has gone wrong in the connection. It'll become very slow. Things will go out of sync. And so it really causes a problem when this is done wrong. And actually that, you know, a smart system would really quickly be able to detect that something is going on. Right? That something is going on. Because as one of the students today mentioned, right, you know, what if we could guess the numbers and we can break the connection? So that was really the fear, and that's why the sequence numbers have to be, you know, randomly selected. So early on, there was speculation that by being able to guess the next sequence number, an attacker could forge, you know, a connection by spoofing that, you know, the information. Right, so basically because of that, for more security, the sequence numbers are large and selected randomly. So in all purpose, you can't really guess them, okay? So you will not be able to guess them. Usually the size is, you know, something like 32-bit, at least the last time I checked. Could be bigger now. 32-bit number. Right, so these are the characteristics. So it's going to be large, selected randomly via a pseudo-random number generator, and it's, you know, it's going to be like around 32-bit in size. Remember also that, and we'll see later on, when you look at your packets, let's imagine you're looking in Wireshark. Every packet that you look at is going to have a sequence. I think it's called sequence. I can't remember exactly. And an acknowledgement field. right? So there's going to be these two fields because there's basically two directions of the communication. So the client could be sending data to the server could be sending data to the client. They both have, it's like they both have their own stream of data and they both have their sequence for that stream, but they also, so they usually send you their corresponding number for their stream plus also acknowledge your number, right? So you'll see that. That's the general description of it. I think, you know, we're running out of time, so I will leave that part, that whole process for the next lecture. But just right now, I just wanted to kind of mention. So whenever you look at a packet, so this is a packet. Right, so this is a packet, and let's say you're looking at it in Wireshark. So this packet basically then will have all the fields that it needs to have, and in particular, it's going to have a sequence number and an acknowledgement number. And this is actually, if you want to take a look at this, this is already described. I have a slide for this, so we'll also look at the slides later. I believe I have this. So you should be seeing the slides. Right, so you can see that there. This is a very nice example, actually. I would recommend that you guys, we'll cover this in the next lecture, but make sure you take a look at these. Not ARP yet. Yeah, here. So Tcp Sequence Prediction. So we'll go over these slides, and in particular, it's actually a good exercise. Grab a paper and pencil, or electronically, however you want to do it. There's basically a communication between host 1 and host 2, and try to work this out, you know, try to draw it out, you know, that exchange. That'll be very helpful because understanding this is the only way that you'll be able to do that TCP session hijacking problem, because you'll have to steal those numbers from Wireshark to be able to do the attack successfully. All right, guys, so that's basically, yeah, let's stop here. I'll stay for a few minutes for those of you that might have questions. But we'll pick up here with TCP session hijacking next lecture, which will probably be Tuesday, right? Because on Thursday, we have enough already with the Syn flooding to start one of the problems in the lab. So on Thursday, the plan will be, I'll go over the PDFs, point out more information there, and then, you know, get started with the lab. Also answer questions about the previous labs if you have them. And then probably the next lecture, then we will pick up here on TCP session hijacking, but not as homework, but just as an exercise for yourself. Read through this and try to get a sense. You don't have to memorize it, just get a feel for it. All right. Okay, so at this point, I'll stop the recording.